Welcome. In this video I'm going to show you how you can obtain a one-sample rank biserial correlation coefficient using R. I'm using Jupyter Notebook, but the R code should also work in, for example, RStudio. I'm currently using R version 4.3 and the basic packages installed are these, which should be the ones that come with R. This is a measure of effect size usually. There's a one sample and paired samples version, both of which are simply actually the sum of the ranks of the scores below and those above the average, the difference between those two, or not average, the hypothesized median, as a proportion over the total sum of ranks. There's a different formula for the ones that is for the independent samples, but I have separate videos on those. To show you how this can be done, I'll load in some example data. So from the General Social Survey from 2012, adjusted slightly for these example purposes. And I actually don't need all the data, I just need one field. I'm going to be using account sci, which is the account scientific, which has the responses on how scientific is accounting. I'm going to be storing that as ORT field. And to give you a quick impression, the table shows that, for example, 348 people thought it was not too scientific. Just to put all those different options in the proper order, a small vector, and then my own library. My own library is not available on CRAN, so you need DevTools, and then you can use install GitHub and then link to my GitHub account. After that, you can just import it as any other library. And it has a function R for correlations and then rank biserial OS for one sample. It mentions here append a series, but that's not correct. And that's for Python. It should just have the data, a vector with the categories, so you can actually enter those two. If the data is numeric, you don't have to specify the levels. And the hypothesized median is the, if you don't specify it, it will use the mid-range. So the maximum plus minimum divided by 2. Right, if I type the name of the function, give it the data and the coding, it returns actually two things: the hypothesized median that was used and the correlation coefficient. For a rule of thumb, you can use the function th for thumb rules and then rank biserial and just grab that value, and in this case it can be classified as medium according to Cohen. Right, and that's how you can obtain the one sample rank biserial correlation coefficient with R and my stikpetR add-in. I hope this video was helpful and thank you for watching.